All right, today we are doing 3.1 in geometry, which is parallel lines and transversals. All right, so the objectives, my goodness, if I could talk, are we're going to identify transversals and related angles formed by a transversal of two lines, and we're going to prove and apply properties of angles formed by a transversal of two parallel lines. Okay, first of all, a transversal is a line that intersects, so it intersects two or more coplanar lines in more than one point. So in each of these, okay, it says line T is the transversal. So get out your highlighter, okay, and I want you to highlight line T because it's the transversal. So here it's T. It intersects two lines. Okay, and then in this one, the transversal again is T. We're making it pretty obvious with naming it letter T, and it intersects three lines. So all three of those are just transversals, a line that intersects another one. Now this last one, there is no transversal. Okay, so there's no transversal here because there's only one point of intersection. Okay, if I had a transversal, it has to cross two of the lines. Okay, if I drew a line like that, that would be my transversal. But if there's only one point of intersection, we don't have a transversal. Okay, so you're going to need to know that because transversals are super important with some of our shapes. Okay, let's go on down here. Okay, when a transversal intersects two lines, it forms special angles, and this is why you have to know which one the transversal is. So it's going to form some special angles. Okay, so I'm going to highlight my transversal here in yellow. Okay, so notice this time it's not, or it's still named T. Again, we're trying to make it easy for you, but it won't always be T. Okay, so different types of angles that we can have when we have a transversal. First up is corresponding. These are on the same side of the transversal and the same side of the other lines. Corresponding lines are. Okay, so that means 1 is corresponding to 3. Okay, because they're on the same side of the transversal, they're both to the left of the transversal. All right, and it says they're on the same side of the other line. They're both on top of line L, and 3 is on top of line M. So angle 1 and angle 3 are corresponding. Then we're going to have angle 2 still on the left side, but now it's on the bottom of line L. What is it corresponding to? Excellent, angle 4. So this is going to be angle 2 and angle 4. All right, what if we go to the top and we say, all right, well, let's go to the right side of the transversal on top of L would correspond with which angle? 7, because it's on the right of the transversal and it's on top of line M. So we have angle 5 and angle 7. Make sure you're using those angle marks. Okay, and the last set, angle 6, it's to the right of the transversal, so it's over here, and it's on the bottom, so it's below the other line, L. So we have angle 6 and good, angle 8. Those are corresponding angles. All right, now I get the joy of erasing all this. You may not have that benefit, so you may have to redraw yours. Okay, you could draw it smaller, even. That's okay. And we're going to look at alternate exterior. So it's in the name, okay? Alternate exterior. So alternate or opposite sides of the transversal and outside the other lines. So they're on opposite sides of the transversal. So first of all, if I pick angle A up here, so it has to be on the opposite side of the transversal. in that case, my options are 5, 6, 7, and 8. But it says it's outside the other line, because see how 1 is outside? Okay, it's exterior. So what we're talking about here is anything inside here, inside those 2 other lines, that space is called interior. So we want stuff exterior to that. So 1 is exterior, and then we have to go to the other side, the opposite side, and outside of the other line. So it's down here, 1 and 8. So angle 1 and angle 8 are alternate exterior. Then we have another set of alternate exterior, okay, because we have angle 5 and what angle? Perfect, angle 4 would also be. So angle 1 and angle 8, angle 5 and angle 4. Now we're going to look at alternate interior. So same thing with alternate, they're on opposite sides of the transversal, and they're between the other lines this time. So they have to be in this interior. Okay, so it's a little hard to see. So we're going to go interior now. Okay, so this one is angle 2 because it's interior. So angle 2, and we have to go to the opposite side and down. So it's going to be angle 7. Those are alternate interior angles. Okay, and then my color doesn't want to change, sorry. Okay, and then if I pick angle 6, it's going to be alternate interior to angle 3. Very nice. Good. All right, I'm going to erase one more time, so you might have to draw another diagram to help yourself out. Okay, you might have to redraw those lines. Okay, so again, we still have this transversal because that's what's making these angle relationships. Okay, and so now we're looking at consecutive interior angles. Okay, so interior, we know they're inside. They're on the same side of the transversal and between the other lines. So now we're on the same side and between the lines. So angle 2, let's remember back. Okay, everything in here is interior because that's part of the definition. Same side of the transversal between or interior to the lines. So angle 2 would be consecutive interior with which other angle? It has to be on the same side of the transversal. My only option there is 3, right? So this is angle 2 and angle 3. Those are consecutive, sorry, let me make that a 3. Those are consecutive interior. What about angle 6? It's interior, so does it have a consecutive interior? Yes. Angle 7. So angle 6 and angle 7 are consecutive interior angles. All right, excellent. So there's a lot of angle names that you will have to memorize, and you may want to add some definitions to your flashcards even, because they're going to be super important for you to know. Okay, next up then, we're going to move down to our first postulate. So we have corresponding angle postulate 3.1.1. Okay, so this says if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. This is huge. Okay, so our corresponding angle postulate, if 2 parallel lines are cut by a transversal, corresponding angles are congruent. We're going to have a lot of these with parallel lines, a lot of really awesome rules. So first of all, this triangle mark, okay, these mean parallel lines. When you see those two arrows, or if you put two arrows on a set of lines, it means that they're parallel. Parallel lines are super important in geometry. You have a lot of special postulates and theorems that are going to come when you have parallel lines, like this one. Okay, so we know corresponding angles are congruent if the lines are parallel. So that means we have to know the definition of corresponding that we just learned. Okay, we have to know the definition of parallel. So let's look at this example. It says find the measure of each angle if the measure of angle 4 is 53 degrees. Okay, I'm going to write this in here. 53 degrees. We know some things. Okay, first of all, we know the lines are parallel. So that's helpful. Okay, we already know that vertical angles are congruent. So angle 4 is congruent to angle 7. Okay, so angle 4 is congruent to angle 7 because the vertical angles are congruent. All right, so we know that angle 7 equals 53 degrees, or the measure of angle 7 equals 53 degrees as well. Okay, then we can figure out the measure of angle 3 because the measure of angle, so angle 4 plus the measure of angle 4 plus the measure of angle 3 equals what? Because we have a straight line in here, right? That's a straight line, that transversal. So this is 4 and 3 are a linear pair. They make a straight line. Linear pairs are supplementary. Supplementary angles are 180 degrees. But if we know the measure of angle 4 is 53 degrees, right, we can replace that. We can use substitution and say, okay, well, 53 degrees plus the measure of angle 3 is 180. We can solve this equation. So the measure of angle 3 is 127 degrees. Let me put a box around this one. Okay, so we know angle 3 is 127 degrees. Well, angle 3 and angle 8 are vertical angles. So we know angle 3 is congruent to angle 8. Let me put a congruent because, again, vertical angles are congruent. So the measure of angle 8 has to equal 127 degrees also. So we're going to put 127 degrees here. I should have put 2 lines there. All right, so these two are congruent. And this one's 53. Whew. All right, so we were able to figure out the angles of all 4 of the, or the degree of all 4 of these angles from things we've already learned. Now we need to bring in the new stuff. Okay, so we have parallel lines. Yes, we have parallel lines that are cut by a transversal. Check, there's the transversal. Then the corresponding angles are congruent. Well, time out and back the train up. We need to figure out which of these angles are congruent to which of these angles up here. That's what we're talking about, because corresponding angles are congruent. So, which angles are corresponding? Okay, one other thing. Let me erase all of this junk so we can see a little bit. Because corresponding is very like cool stuff here. Well, you can't really see that. I want to draw it where you can see it. Okay, so this is angle 3, 4, 7, 8. Hopefully that takes everything. All right, so I just drew this. I'm hoping it'll take it. It will. Okay, so notice I just copied this, right? 3, 7, 4, and 8. It's taking a little bit of extra stuff with it, but it's okay. I don't want to type. There we go. But if I move this up to the other one because they're parallel, I can, it's like superimposing them. You can visually see, I can visually show you that these angles here that were down here, 3, 7, 4, and 8, are congruent because of this parallel line. They are congruent to the angles up here. So and they're corresponding, okay, because they have the same position. Okay, the angle on the top left here, got to get rid of all these extra marks. Okay, the angle on the top left here is angle 1. That corresponds to angle 3. So angle 1 is congruent to angle 3, okay, because they're corresponding. Again, this only works with parallel lines. But then angle 5 is congruent to angle what? Yes, 7, because it's on top of the parallel line and to the right. So angle 5 is congruent to angle 7 because they're corresponding. Okay, angle 2. What's angle 2 congruent to? Good. Angle 4. Because why? They're corresponding. And corresponding angles on parallel lines are congruent. All right, last one. Angle 6 is congruent to what? Yes, angle 8. Because they're corresponding. Corresponding angles of parallel lines are congruent. I'm trying to beat this into your head if you hadn't figured it out yet. Really working on that. All right, so you know you can go through and put all the other measures. If angle 1 is corresponding to angle 3, and we know angle 3 is 127 degrees, this is 127 degrees. Okay, we know angle 6 is corresponding to 8, and we know the measure of angle 8 is 127 degrees, so this one's 127 degrees. Angle 2 is corresponding to angle 4. We know angle 4 is 53 degrees, so this one's 53 degrees. And angle 5, okay, we're going to back here. Angle 5 is corresponding to angle 7, and we knew angle 7 was 53 degrees, so this angle is 53 degrees. Hopefully your paper's a little bit cleaner than mine and not quite so messy. But that's it. Like there's all these connections. When you are doing geometry and like doing the math of geometry, it's like there are connections everywhere that really just show like the glory of God and how things are so connected and just work out so perfectly. It's phenomenal. All right, let's keep going though. All right, next up then, we're going to go to the next theorem. The next theorem is the alternate exterior angle theorem. Okay, so it's telling us if two parallel lines are cut by a transversal. Okay, so again, we've got parallel lines cut by a transversal, then the alternate exterior angles are congruent. So alternate exterior angles are congruent if it's parallel lines. Alternate interior angle theorem. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So check this out. If we have parallel lines, corresponding angles, alternate interior angles, and alternate exterior angles are all congruent. Now, we're going to go on. If you flip over to the back, I'm not flipping yet, but we have the consecutive interior angle theorem. If two parallel lines are cut by a transversal, then the consecutive interior angles are congruent. Okay, if parallel lines are cut by a transversal, then consecutive interior angles are congruent. It gets pretty crazy that way. All right, so all of these you're going to get to apply later in some of your work. There's a lot more theorems today, not as much application necessarily. Okay, next up is the perpendicular transversal theorem. Okay, so in that one, if a transversal is perpendicular, okay, so remember perpendicular symbol is this. So if a transversal is perpendicular to one of two parallel lines, it is perpendicular to the second line also. Okay, so if I've got two lines like this, okay, and I know these two lines are parallel, so I have my little triangles on them. Okay, and this line comes here, and I say, oh, it's perpendicular to the bottom line. This theorem, okay, also tells me that, oh, then that means it's also perpendicular to this line. Okay, that's what that theorem is telling us. Okay, let's look at example 2 then. Example 2 says, find the measure of each numbered angle if the measure of angle 1 equals 7y minus 15 degrees, and the measure of angle 2 equals 10 times the quantity y plus 11 degrees. All right, so I'm actually going to go ahead and move this up so we have some more space. Okay, perfect. I have more working space, because I like to label things, and it's a good habit. I want you all to learn to do that as well. So the measure of angle 1 here, we're going to say, is 7y minus 15. And the measure of angle 2, which is down here, is 10 times y plus 11. All right, perfect. And we're going to find the measure of each numbered angle. So I have to find the measure of angle 2, 3, 4, 5, and 6. So what are some things that we know? First of all, let's throw out information that we know. Okay, we know that these lines are, I'm going to connect them there. So we have parallel lines. Because this is the thing, you have to identify what you know. Okay, so that's the symbol for parallel lines. Okay, here we know this is perpendicular. All right, very nice. Okay, so then what else can we figure out? If I'm looking, like if I'm looking at this intersection, because I know the measure of angle 2 here is known, I know that angle 2 and 3 are congruent. Okay, so angle 2 is congruent to angle 3. How do I know that? Because they're vertical. So these are vertical angles are congruent. This is exactly what I would put in a proof later. Okay, so that's nice. If I'm also looking at this, angle 2 and angle 4 are a linear pair. So I know that the measure of angle 2 plus the measure of angle 4 equals 180 degrees. So that might be helpful once I know the measure of angle 2. Let's see. The one up above is a little sketchier because I have lots of intersections going on there. If I just look there, it's a little harder for me to see maybe my transversals. Okay. And maybe it's not if you don't get distracted by this. So if we look at the parallel lines and the transversal only, I'm going to highlight this transversal here, okay, and our parallel lines, then maybe you could see that angle 4 is congruent to angle 1 down there. Do you see that? Because it's from the transversal up to the parallel line, from the transversal up to the parallel line. So angle 1 is congruent to angle 4, and those are, do you know the position? The name of those? Okay, because they're both below the transversal and on the right. So this is corresponding angles are congruent. Corresponding angles of parallel lines. Let me add to this. Vertical angles are always congruent. Corresponding angles of parallel lines are congruent. Let me spell that out a little bit more. All right. So angle 1 is congruent to angle 4. We just had this theorem up above, right? The perpendicular transversal, because we have a perpendicular here. So if this one, this transversal is perpendicular to this parallel line, then this one is also perpendicular. Okay, which means, oh, hey, angle 5 has to be a right angle. So angle 5, the measure of angle, and we could walk this back a little bit so I can show you. Angle 5 is congruent, well, we don't have a number, so never mind. Well, I'm going to say the measure of angle 5 equals 90 degrees. Okay, and it's because this vertical angle is 90 degrees. Is that helpful in any way? Well, sure, it's helpful because that means angle 1 plus angle 6 is going to equal 90. So we could say, oh, well, the measure of angle 1 plus the measure of angle 6 has to equal 90 degrees. Well, we have a lot of stuff here, but how do we, and we could keep going. We could come up with all kinds of relationships. But how are we going to find out the measure of, like, what the measure of angle y, or like y is, so that we can actually solve for any of these? See, sometimes that's the trip, is being like, okay, well, I know all of this information. I found out all of this stuff, which is all great. But how do I put it all together? Okay, so where is the connection that's key for you? And it's this one right here. Okay, it's knowing that the measure of angle 1 is congruent to angle 4. Because if angle 1 and angle 4 are the same, that means this is 7y minus 15. And then I know angle 2, this is the second step. The measure of angle 2 plus the measure of angle 4 equals 180 degrees. Now I can use substitution and I can solve this. Okay, so let's bring this down here. The measure of angle 2 is 10y plus 11. And I can write it here actually, 10 times the quantity y plus 11 plus the measure of angle 4, which is 7y minus 15 equals 180. That's it. I use substitution. So now I can go through and solve this. So we would distribute. So I'd have 10y plus 10 times 11 is 110. And then plus 7y, I don't have anything to distribute, so I'm just going to write minus 15 equals 180. All right, then I'm going to combine like terms. 7y plus 10y plus 7y is going to give me a 17y. Then I have a positive 110 minus 15. That gives me a positive 95. So plus 95 equals 180. Balance. So we're going to subtract 95. So 17y equals 85. Divide by 17 to isolate my variable. Y is equal to 5. All right, once I know that, I've done all this work and I have all the pieces to plug it in. Okay, so if y is 5 degrees, then here we would do 10 times 5 plus 11. That's 10 times 16. So this is 160 degrees. Okay, so then I'm going to go back in and start piecing everything together. So angle 2 is 160 degrees, and so is angle 3, because they're congruent. Okay, and you can, if you had some more room, you could write that out here. Angle 4, 160 plus, right, filling this in, we could say, well, 180 minus 160 equals 20 degrees. And that's the measure of angle 4. So 4 is 20 degrees. 4 is congruent to 1, so 1 is 20 degrees. Okay. Ooh, then 1 and 6, we said the measure of 1 plus 6 had to be 90. Well, if the measure of angle 1 is 20, this is 20 plus the measure of angle 6 equals 90. We subtract, and we would get the measure of angle 6 equals 70 degrees. So then here we've got 70, and we already had this one at 90. So you have all of the measures of the angles because of the theorems and the rules, right? The definitions, the theorems, the postulates that we've learned. So this is why it's so important for you to make your note cards, right? Your flashcards of the theorems and things, and to review them, because we're just going to keep building. They're never going to go away this year. We're going to keep building on what we have. So your homework tonight is on the front there, page 111, and I will see you tomorrow. Have a good one.